In this video, we are going to solve a very simple problem based on magnetic moment. This was asked in GATE exam 2010. A 6-coordinate transition metal complex is ESR and mass bioreactive. The effective magnetic moment of this complex is 5.9 Bohr magneton. The metal ion with its oxidation state and the number of unpaired electrons are. It is a 6-coordinate transition metal complex, so it is octahedral complex. The complex is ESR and mass bioreactive. For a complex to be ESR active, there should be unpaired electron. Further, this is confirmed by the magnetic moment. The effective magnetic moment of this complex is 5.9 bm Bohr magneton. For time being, I skip mass bioactivity. Let us consider it is ESR active and the magnetic moment is 5.9 bm. The magnetic moment is calculated by the formula square root of n into n plus 2. What we get is 5.9 bm. This is almost 6. Let us consider as 6. If you consider as 6, this value should be 36. When you take square root, you will get 5.9, that is 6. You may get 36 only when you have 5 unpaired electrons. You will get around 35. If you take square root, it will be 5.9. So in the given complex, there are 5 unpaired electrons. Now let's go to the given options. The case of Fe2 plus, there will be 6 electrons in the d orbital. When you arrange the 6 electrons in 5 orbitals, there will be 4 unpaired electrons. Irrespective of the field, whether it is strong field or weak field, you will not get 5 unpaired electrons. If it is strong field, you will get 0 unpaired electron. It will be ESR inactive. So I can eliminate this option. What about Mn2 plus? Mn2 plus will be D5 system. If the ligand is weak, you will get I spin complex. You will get 5 unpaired electron. So it is possible. What about Fe3 plus? Fe3 plus is also D5 system. What about the number of unpaired electrons? We have calculated it is 5. Based on that, I can eliminate this option. You will get this if the field is strong. When the ligand is strong ligand, you will get only 1 unpaired electron. The 5 electrons will be filled like this. There will be only 1 unpaired electron. But based on the magnetic moment, we can conclude that there are 5 unpaired electrons. So based on that, I can eliminate this. Now the question is, what about the metal? Whether it is manganese 2 plus or iron 3 plus. Iron is the most common example that we discuss under mass spectroscopy. You may have no idea about the activity of manganese 2 plus in mass spectroscopy, but you should have studied iron in mass spectroscopy. Iron is mass bioreactive. Manganese is not mass bioreactive. Based on that, I can eliminate this option. So correct answer is D. Here I have the periodic table. In that, the elements that are mass bioreactive are given in red. If you follow this periodic table, it will be very easy to remember the elements that are mass bioreactive. The first row transition metal, we have iron, nickel and zinc. Only these 3 metals are mass bioreactive. In the iron group, iron, ruthenium, osmium, all 3 are mass bioreactive. Technetium and silver they are also mass bioreactive. All the elements in the third row transition metal are mass bioreactive. Apart from that, we have germanium, tin, antimony, tellurium, iodine, krypton, xenon. They are mass bioreactive, and potassium is mass bioreactive. I hope it will be easy for you to remember the mass bioreactive element following this periodic table.